All right. Hey, everyone. Hey. How's it going? Long day, yeah? Sad that I cannot see most of you, like some people here, but yeah, that's it. But yeah, I'll try to still interact, behave as, you're still there. You are there, but I'll try to see all of you. So, are you tired? Yeah, I can imagine. I'm glad that you're still here after a long day. Really glad to see the Poland, the Warsaw community. And thanks, Derek, for having me here and the whole team who are organizing it at this level. I'm so glad to be here. Can I have a huge round of applause for yourself because you're still here and enjoying the whole thing? Awesome. So I'm going to extend my slides here. Right. So my talk is titled JavaScript Surprises. Now, as the name suggests, this is not going to be a lot of things that you've not heard before or you've not used before. This is actually things that we use on a daily basis. This is actually things that we kind of try to adopt the new features of JavaScript. But we are going to look at it from a bigger picture today. We are going to look at it from how the world uses it, right? How all of us engineers at work play around and do our adventures with JavaScript. And that's why I called it JavaScript Surprises, because we use all those features, but we don't really know how or what's the best way to leverage all the tools and features that JavaScript provides us. So a bit about myself. My name is Nishu Goel. I am a software engineer at epilot. And most of my work revolves around building the web, breaking the web. Isn't that a part of it? And yeah, I try to keep exploring and understanding more of web. I'm also a Google developer expert for web technologies. So that also includes a lot of researching around the web. So now, why am I talking about this? So a little backstory on that. Last year, I wrote a JavaScript chapter for the annual State of the Web report. And it's a report which basically gives you the statistics of how JavaScript features are used, how new features are being adopted. And it spans through millions of websites to do that. It's not like a survey which asks people. It's not like something that's done on Stack Overflow or GitHub where developers could give their opinions. But it's actually coming from websites. And this one is based on Chrome user report data, which is this year. It was year 2021 when I wrote this chapter. And it included 8 million websites, which are the websites that we enter into Chrome on a daily basis as developers. It could be e-commerce websites. It could be anything, any other websites in general. So a lot of the stats that you see today are going to be based on this. Excited? OK. So let's talk about how JavaScript has evolved, right? The speed and consistency with which JavaScript is growing is tremendous, isn't it? We started using JavaScript on the client side, and then here we are where we can run servers within browsers. Now, before I go on to talk about what I mean by that, can anybody give me, just throw some words what I might mean by saying run servers within browsers? Some words? Node.js, OK. Web containers, that's exactly the term that I was hoping to hear. So now there's something called web containers. It's something that recently got launched by StackBlitz. And I think it was the last year when StackBlitz launched web containers, which is basically some, it's in the background uses WebAssembly to let that happen. But now, for example, if you're using online IDEs like StackBlitz or Code Sandbox, you can run Node.js within your browser. You don't really need to set it up on your local machine. And now, that takes us close to what the original vision for web browsers was, that a browser should be a mini operating system. You should not have to go to your local machine to do half of the stuff, which really makes you kind of using your computer and sometimes using the browser for maybe just loading the websites and so on, right? You really want to use the web to build the web. And I think towards the end of this talk, we'll try to see how close we are towards this, approach. We'll try to see how close we are towards, building the web by using the web, and how close we are in terms of, browsers being a mini operating system. If I ask you right now, what do you think how close we are to, using a browser as a mini operating system? Percentage? 20%, okay. What else? So, okay, so let's figure that out from some of the stats that we see today. Since we talked about, so this is one example of, this is a Next.js application, and this is the screenshot of StackBlitz. It looks like VS Code almost. So yeah, this is a screenshot of StackBlitz, and it allows you to run Node.js and any file, and you can basically run the whole server within your online IDE. Now, since we were talking about the usage of JavaScript and the way it's evolving, right? Let's look at some stats. So this is the first data that I got analyzed out of those 8 million websites, which is how is JavaScript bytes loaded per page. And if you look at this, on a median page, you would see that there's 427 kilobytes of JavaScript bytes that get transferred. And the last year, in the year 2020, or before any of those years, the number was almost, this is 427, right? The number was 360-something bytes. So you can imagine with that difference about the growth with which JavaScript evolves. And it's not just this, right? This is about the total transfer size. But imagine how much JavaScript is actually used, and we'll come to that. So to look at an even bigger picture, let's look at how JavaScript was used back in the year 2005. Script was not even one of the top elements. And now in the year 2021, it's one of the top 10 elements. And now it sounds obvious to us, right? Because, we cannot do without script. But then in the year 2005, it was not even one of the used elements. So I think that's the bigger picture we need to look at, right? We keep using these things, but we don't realize that how fast we are growing or how good we are growing. So yeah, that kind of sets a context of why we are talking about JavaScript growing that fast. And now, since we are talking about JavaScript being transferred and loaded, how much of it is actually being used? I think that's the right question that we should ask ourselves. So the percentage that's unused from the total bytes that we transfer is 36.2%. And that accounts for, before that, can somebody remind me what was the total JavaScript that we were transferring? 427 kilobytes, right? Yeah, so if you if you account that, if you calculate that, that falls for what? 155 kilobytes of JavaScript being unused from the total of 427. Now, does that sound fair to the browser? Does that sound fair or justified? Does it sound like a right thing, wasting that much percentage when we have so many frameworks and so much data? Somebody said something here? Yeah, sounds like a crime, doesn't it? So now I'm not just giving you stats, but I'm also giving you, how you could, kind of figure out the amount of JavaScript that's unused. And we use this query from, there's this database of HTTP archive, which you could also access. And I have resources which I could share with you later. So if you want, you want to look at the bigger picture and you want to go yourself and figure out how much JavaScript is unused, you could go into that database and check for yourself. So if I go back, yeah, this is the whole transferred bytes. Now imagine, most of the transfer data that we do, the JavaScript that we transfer, is mostly compressed, isn't it? Now imagine the decompressed JavaScript that we transfer, because then that's going to be much larger. That's going to be much beyond 36.2%. So if I go further now, whenever we talk about unused JavaScript, unused code in the browser, how many of you have seen such a view where it tells you to, where the analysis tells you to reduce unused JavaScript? We do see that, right? When we are working on the performance of our application at a point, we always come across this. And what's the most obvious suggestion? Code split your application, isn't it? And then it also gives you potential savings and stuff. So maybe before reaching that step, Could you do something before that that could help you, analyze your bundles and analyze your overall import costs that, is added? So one thing that you could do as a step in your development process is analyze your bundles, right? Always ensure what bundles you're using. Always see if some library that you're adding for a small thing that you want to do in your application might not be worth the cost that it's adding, might not be worth the amount of bytes that it's adding to your application as a whole. So for example, in this one, I see that there's React Beautiful DND, which takes like a lot of bundle size, right? Now, I know that in my application, I'm using it for a small thing, and that's not worth the size that it's adding to the overall bundle. Maybe I could look for an alternative. Maybe I could see if I could only access what I'm looking for, or in general, just use my own implementation, right? So some alternatives like that. This is one step where you're analyzing your bundle. The second step could be, while you're coding, there's this extension called import cost. It's a VS Code extension, and you could use that to, whenever you import something, it tells you right away that, this seems to be big. This is highlighted in red, and it seems to be a bigger size of library that you're adding. Do you really want to add that? Do you maybe want to look for an alternative? So stuff like that would really help you to analyze your bundle while you're coding. It's not when you've thought about finally fixing the performance of your application. It's during your development process. So we saw that. Now, since we're talking about imports, we sometimes try to dynamically import stuff, right? Because that sounds like an easy or a good solution for your importing job. Because you want to not import all of the stuff in your first bundle, but then you want to dynamically import it when you later need it. But when we were looking at the websites who are dynamically importing stuff, only 0.34% of those 8 million websites were using the dynamic import. And it was sad to see, because whenever we see that there's a huge bundle, we should code split, we try to dynamically import stuff. But that's not that doesn't seem like it in the bigger picture. Now, since we are talking about transferring JavaScript, we should also talk about how the JavaScript is requested. How do we load it? So if you see this little arrow there, right, the red arrow, that much, the time before that was the time where all the parsing, the downloading of the scripts, and execution was happening. And after that is when I could finally, my application could finally become interactive, right, where I could interact with the application. And that was like 22 milliseconds or something. Yeah, so that's like a lot of time. Do you want to wait for that much time? Script element is mostly render blocking, right? If you don't load it asynchronously. One way of doing it is, what is it? What do we use on a script element? Pretty basic. Async, defer, all of those, right? So if we have the async attribute on, it would ensure that the downloading part of the script does not block the browser from rendering the stuff. But the execution part is still blocked. The browser still has to wait for the execution to finally show you the interactivity of your application. So that helps, but there's still some blocking, render blocking that's happening, right? So we'll see how many websites are actually using async scripts. The other way is to use defer. And what that helps us with, it also saves us from the execution phase. So the browser defers the the execution phase until the application becomes interactive. So the browser is now not waiting for the execution phase to show you some stuff on your application. So that also helps the applications a lot, but you have to ensure that you're using it in the right place only when required. You're not worsening the performance by just using everything that seems like it might help the overall picture. And when we looked at how many websites were using those async and defer attributes, it looked like this. It was good to see that a lot of scripts were being loaded asynchronously with the async attribute, but defer, which could really help them by also deferring the execution phase, was not used as much, right? It was only 42% of websites from those 8 million websites. And now there was also something interesting that we saw. We saw that a lot of websites were also using async and defer both attributes on the same script element. And now it was something to be used when there were older browsers, So to support, for example, Internet Explorer, we would use async and defer, so that if the browser does not support async, it could use defer, right? It could fall back to defer. But now, with mostly most modern browsers being there, this anti-pattern has still not gone. It's still being used a lot. And then when we saw the percentage, this was the year 2020, and we tried to figure out how many, which websites were using this pattern where they would use both async and defer on the same script element. And who do you see as the topmost culprit? stats.wp.com, right? So this caught a lot of traction on Twitter when we actually published this, and turned out that the team came back saying that what, we're going to remove all of those cases where we are using both async and defer on the same script, because now it doesn't make sense, because now we don't have to support older browsers. And the percentage in year 2020 of both of these attributes was 11.4% of mobile pages using such pattern. Then, when I was writing the chapter in year 2021, I expected that this should decrease, right? Because the problem was going to be solved. The only difference that I made in when I wrote the chapter in the year 2021 was I was looking for the final page load, and after that I was checking the usage of async and defer. So it was like the full page load and not just the initial page load. And turned out a lot of websites were dynamically injecting scripts with both async and defer to be true. And the percentage, increased from 11.4% to 35.6%. And this was really surprising at first, because we didn't realize that we are looking at the elements, the attributes, after the complete page load. So it turned out it was happening dynamically. And if you see here, it's mostly the analytic websites that are doing that. Pivik is one of the analytics website that does it, and other analytics website as well dynamically inject the script with such pattern. So in the year 2022, when Web Almanac is already out, if you're interested, you should go and read that. You would see that the number has really gone down. The WordPress websites are not using it, or dynamic injection is also less with both async and defer to be true. So that's quite an improvement with stuff that we do with analyzing stats. Now we also wanted to see the usage of web workers. Everybody aware with what web workers are? It's like a web platform feature to basically allow you to run some expensive stuff on another thread by not overwhelming the main thread and freeing it from some expensive calculations. So this was the script that we used to see how many websites are using web workers by basically using the feature as worker start that would tell you that this is a web worker. And turned out it was good to see that at least 12% of websites, because this was not an expected number, 12% of websites were using web workers. And there's also a niche technology called worklets. Anybody heard about that? Worklets? I'm sorry, I cannot see your hands if they are up. So yeah, worklets is a niche web platform technology, again, like a feature. What it does is basically allow you to, allow you access to the lower level access to rendering pipelines for painting and audio processing stuff, which is really expensive, and it by default runs it for you on the second thread, another thread, not overwhelming the main thread. And it's really fast because it saves your main thread from doing these jobs. So it's only this number, right? Only these many websites that are doing that. And it's not surprising because it's quite a niche technology. Not everybody does audio processing stuff and paint processing stuff in their applications. So it's still OK. Moving on, since we're talking about JavaScript, we should also talk about different frameworks. And I'm not sure how surprising this is for you, but jQuery still dominates the world. It's like the top JS library that's still used. It's like a staggering 84% of websites using jQuery. Now you'd ask me why. Mostly WordPress, right? WordPress is one reason, but when we looked at it, it's mostly 35% of websites who are the reason for the jQuery adoption because of WordPress. The other reason is our third-party libraries that we use, right? Indirect adoption of jQuery by the third-party libraries that we use, when we still have those native DOM APIs which kind of do the job now, right? So if I go back, you would see that we keep on talking about frameworks all the time, but if you look at the bigger picture, it's like nowhere, right? I mean, I know it's via indirect adoption or WordPress, but still, if you talk about top JS libraries, it's jQuery. And a funny thing here, when this chapter was published, we published this on Reddit, and the Reddit population went crazy about it, that, oh, wait, jQuery, no. Then everybody coming in and talking about, you know what, I'm still a jQuery developer, so it makes sense to me. So everybody adopting it all of a sudden because of this picture. So moving on, this is what I already talked about. WordPress accounts for like 35% of websites. So that is one reason for jQuery's adoption. And we could justify it by these versions. WordPress was using another version in before, but then when they moved to a different upgraded version of 3 point something of jQuery, we could also see that version difference in the adoption of jQuery. So it made sense there. And in the end, I just want to say that as developers, do you want to build cool websites, good-looking websites, functional websites, or do you want to focus on lazy loading? Do you want to focus on, thinking how to load your script? Do you want to asynchronously load it, or do you want to defer it? Maybe not, right? A developer should not have to do all of this. And I think you attended a lot of talks today which talked about, no hydration, auto lazy loading, where the framework should take care of it for you. You shouldn't, as a developer, have to do it. And this was one framework that was being already talked about today, right? And I think this really solves a lot of problems that we saw today. This really solves a lot of stat numbers that we saw today, which could really be improved in the coming years. So yeah, that's about Quick. I don't think I need to say any more about Quick, because there was a good session already about it. And this is the resource that I want to give you. You could take this away. You could only change the year number here if you want to check the stats of different years. So it's really interesting. And it's not just the JavaScript chapter. You could also go on to see the performance chapter, CMS chapter. There's like 22 to 24 chapters, which would give you the real picture. And in the end, I would just like to thank you all for being here and attending the talk about small JavaScript stats. Not sure if it was surprises for you, but yeah, you could connect with me on these handles. And before I go, I'm going to ask if somebody is aware of these 3 terms that I'm going to throw out. If someone can explain all those 3 terms to me, they get this little bag that I have here. It's like a simple bag, future decoded, but then I think it's not about the giveaway, but about that feeling of achievement that we get after answering questions. So those 3 terms, and I'm not going to give you the full form of those, because that would make it kind of obvious. So it is LCP, FCP, and FID. I don't want just the full forms. I would want somebody to explain it to me real quick. Anyone? I would first want it to be from somebody from the attendees. And it's OK if you don't want to answer. I love the bag. I would love to keep it with myself. But yeah, if you would like to answer, go ahead. I would repeat it: LCP, FCP, and FID. I could. Does anybody know that? Or you just don't want to stand up? It's a lazy day. Sorry? These are core web vitals, yes. I could give you the full forms if that helps you. I know that really makes it very easy for you, but I can go ahead and do that. LCP is largest contentful paint. FCP is first contentful paint. And FID is first input delay. Anybody wants to answer it now? No? Oh, I'm so happy I get to keep the bag. If any hand was raised up, I didn't see it. You could just say shout out. And I am so happy I'm keeping the bag. Thank you very much. Thank you, everyone.